Okay, beta ji, bismillah. I hope you can see the screen. Is that
Yes,
Yes,
sir.
sir.
okay, beta ji? Suppose that we are having a wire which has a diameter that is 2 millimeter, and it is made up of a material which has 2.5 10 raised to power 3 electrons per meter cube. And speed of electrons here is 0.001 meter per second. Can you suggest me what will be the current here? Any idea?
We have formula V is equal to I over NaL. We can move NaL to other side to make it I as
So
subject.
you can use the formula I is equal to NaVe, nave, right? So
Yes.
how would you use the data? This is the value of n. This is the drift velocity. So n is 2.5 10 raised to power 3. What is area? How would you? The area is area of cross section, right? From the area, by the area we mean the area of cross section. जी बेटा, we are given the diameter. This is the diameter, 2 millimeter. So area is pi into radius. The 2 millimeter diameter, the radius will be 1 millimeter, and millimeter is 10 raised to power minus, right? Speed is 0.01. And what do you mean by E?
Of one electron, which is 1.6 times 10 power minus 19 coulombs.
Very right. Can you please share me the amount of current here? These are the cancel.
To 6 times 10 power minus 19.
Can you repeat?
1.26 times 10 power minus 19 amperes.
Okay, good. I hope Hassan is it the same?
Yes, sir, it's the same.
Okay, let's see. If the wire goes on and we reach the other end of the container, and here the diameter is 0.5 millimeter. Can you share me what will be the speed of current here? V is the drift velocity of electrons. जी बेटा जी, are you there? बेटा जी,
Calculating now.
you will use the formula V is equal to, or the same formula, I is equal to NAVE. So V is equal to the current in a same wire is same. So for current, you will use the same value. And N is the same for the same material. So it's the same a wire, a single wire made up of same material. So N will be same. Area is the difference. Pi here, the radius will be half of 0.5, and it is in millimeter, means -3, and here we have a square. Let me see. Did we take the square here? I guess we forgot.
Because no, we took because 0.01 is no, it's different.
So we forgot this. Now the value is changed, but the process will remain the same, right? So we will continue here. We are not changing the value, and E is this. So beta ji, yes, we calculated it wrong in the previous part. We didn't write, I didn't write the square. But if let's say the square with the answer is this, the current will remain same here as well. Clear?
Yes, sir.
Right? So this is how you can find the speed. Can you note it down, please? Please tell me when you're done.
Done, sir.
Okay. Okay, beta D. I want to remove it. Beta D, next point. Can provide you electric current, electric energy. They are called as sources of energy. But energy can neither be created nor be destroyed. It can only be changed from one form to another. In actual, these appliances, sources of current, which are called, they convert any non-electrical form of energy into electrical energy. For example, cell or batteries, they have chemicals inside them. They convert chemical energy into electric energy. Generator convert mechanical energy into electric energy. Solar panels or solar cells, they convert light into electric energy. Thermocouple can convert thermal or heat energy into electrical energy, right? So in energy in any circuit is said to be voltage. Beta, energy inside any circuit is said to be voltage. But voltage is of two types. One is called electromotive force and the other is called as potential difference. What is the difference between electromotive force EMF and potential difference? Both are energy or voltage. The difference, the voltage which are provided by a source of current, is called EMF. Like if we see 12 volt, what does the battery provide, right? But if it is written 6 volt on a bulb, do you think the bulb will provide you 6 volt or it will consume the 6 volt? Ji beta, what do you think? If on any bulb it is written 6 volt bulb, so what the bulb will do with this 6 volt? It will consume, not provide us. It will use this 6 volt to work. So beta, the voltage which are provided by a source of current, battery, generator, cell, that voltage is called EMF, electromotive force. Shorter form is EMF. Potential difference are the voltages which are consumed by an appliance, right? So potential differences are the voltage which are consumed by an appliance. So what happens? What does a source do? Source converts a non-electric energy to electrical energy. And what when we say a battery is running a circuit, so is the battery moving or is battery is moving something in the circuit? No, battery remains at its own place. Actually, battery provides energy to the charge. Like when we say na a gun, a person killed several persons, other persons by using a gun. So did he hit the person with the gun? No. Actually, the gun gives energy to the bullet. Bullet hits the target. Similarly, when we say a circuit is run by a battery, a source of current, in actual, the source of current is not going to make all the appliance move and goes to each appliance and move it. No, the source remains in its place. It only gives energy to the charge. The charge gives energy to the appliance. So when the energy which is given to the charge is called EMO, electromotive force, EMF, electromotive force, energy which is motivating the electricity charge, right? This is the energy which is given to the charge. While potential difference is the energy which the charge gives to the appliance. They are quite opposite to each other. So EMF can be said to be like income which is coming in over, let's say, in our house, the amount coming in form of salaries, profit is called income. And amount which is going in form of bills, grocery, fee, that is called expenses. Both are amount, but one is coming, the other is going. One is provided to us, the other is taken away from us. So, beta, same is the difference. The voltage which or energy which is provided to the circuit, and actually that is provided to the charge, is called EMF force, electromotive force. And the energy which is taken away from the charge. And who is doing this? Appliances. And those appliances consume energy, that energy of charge. The energy consumed by appliances is called potential difference. Represented by a sign, the potential difference represented by V. And let me tell you why we call this as potential difference. Actually, potential mean energy, right? What happens when the charges enter an appliance? They were having higher energy, and when the charge leaves, let me tell you, the number of electron or charge entering is equal to number of electron or charges leaving. So amount of charge is not used. Then what is used by this? In actual, when charges enter the appliance, they were having more higher energy. And when they leave, their energy is decreased. Like uh, a father takes the family to a restaurant. So do you think that the number of family members will increase or decrease when they enter the restaurant as compared to when they leave the restaurant? No. The number of persons entering is equal to number of persons leaving. We discussed yesterday number of electron entering is equal to number of electron leaving. Then what is used by this? Like the family members coming to the restaurant is equal to family members leaving the restaurant. But the amount with the father is decreased. Similarly, when the charges enter an appliance, they were having a higher amount of energy as compared to when they leave, then their energy is lowered. The difference in energy of charge, this difference in energy of charge is called potential difference. And this is the energy which is consumed by this appliance, right? Here, so beta, now we are going to define EMF and potential difference in detail. EMF is work done in moving a unit charge throughout the circuit. EMF is work done in moving a unit charge throughout the circuit. Or better, how do you define EMF? Work. Whenever we use a word unit, it usually means divide. So work divided by charge. W divided by charge is EMF. This is a work divided done in moving a charge. And unit of EMF is volt. And potential difference is work done by a unit charge in moving from one point to another or moving across an appliance. So now you have to keep this mind, these two words. जी बेटा जी, I hope you can see me. What was the last point you could hear?
In-
So beta, were you able to understand the difference between EMF potential difference?
Yes.
Okay, then can that be all for today then?